We've all heard the story. 66 million years ago, a giant asteroid hit the Earth, and just like that, the dinosaurs were gone. A simple, clean, final extinction. Except, that's not the whole story. The truth is far more complex and a lot more interesting. For decades, we believed a 6-mile-wide rock slammed into Mexico's Yucatan Peninsula, releasing the energy of 10 billion atomic bombs. Tsunamis hundreds of feet high raged across continents. A cloud of dust and debris blocked the sun, plunging the world into a freezing, dark winter. Within months, 75% of all species vanished. The dinosaurs died. The asteroid killed them. End of story. But what if I told you that at the exact same time on the other side of the planet, a second apocalypse was already underway? In what is now India, volcanoes were erupting on a scale that's almost impossible to imagine. For nearly 1 million years, lava flows buried an area the size of Texas under 2 kilometers of rock. These eruptions, known as the Deccan Traps, pumped staggering amounts of climate-altering gases into the atmosphere. So, we have 2 smoking guns. 2 world-ending events happening at the same time. The Chicxulub asteroid impact, a sudden, catastrophic blow. And the Deccan Traps volcanoes, a slow, relentless poisoning of the planet. For years, scientists fought over which one was the real killer. Was it the asteroid's instant devastation? Or the volcano's slow burn? The debate got so heated that some researchers decided to do something radical. They built a supercomputer model and let it decide, analyzing all the geological and climate data without any human bias. What they found didn't just settle the argument. It turned everything we thought we knew on its head. Let's start with the asteroid because its effects were immediate and biblical in scale. Picture it. Spring 66 million years ago. A massive object screamed through the atmosphere and hits the shallow seas of the Gulf of Mexico. Within seconds, it carves a crater 110 miles wide and 12 miles deep. The impact triggers magnitude 10 earthquakes across the globe. Molten rock is blasted into space, only to rain back down, igniting continent-spanning firestorms. Tsunamis taller than skyscrapers scour the coastlines. But the real killer wasn't the initial blast. It was the aftermath. In the days and weeks that followed, a thick blanket of dust and soot blocked out the sun. Photosynthesis ground to a halt. Plants withered and died. Global temperatures plummeted by over 34 degrees Celsius, creating a prolonged impact winter that lasted for years. The base of the food chain simply vanished. Think about a massive herbivore like Triceratops. It needed to eat hundreds of pounds of plants every single day. When the plants died, the herbivores starved. And when the herbivores died, apex predators like Tyrannosaurus rex had nothing left to hunt. It was a cascade of collapse. Interestingly, survival often came down to size and metabolism. Almost every land animal weighing over 25 kilograms went extinct. But smaller, cold-blooded creatures like crocodiles and turtles made it. A crocodile can survive for months without a meal. A warm-blooded dinosaur couldn't. It was a fast, brutal, and selective killer. Now, let's turn to the volcanoes. This is where the story takes a strange and unexpected twist. The Deccan Traps eruptions were immense, releasing trillions of tons of carbon dioxide and sulfur over hundreds of thousands of years. The traditional theory was that this volcanic activity weakened the Earth's ecosystems, polluting the air and acidifying the oceans, making the dinosaurs vulnerable before the asteroid delivered the final knockout blow. It's a compelling idea, a 1-2 punch. But recent, groundbreaking research has completely flipped that script. Computer simulations now suggest the asteroid impact alone was more than enough to wipe out all non-avian dinosaur habitats. The volcanoes weren't the co-conspirator. In a bizarre twist, they might have actually been a savior. How is that possible? Volcanoes release 2 main types of gas with opposite effects. Sulfur dioxide causes short-term cooling, and acid rain definitely bad news. But they also pump out massive amounts of carbon dioxide, which causes long-term global warming. Fossil evidence from ancient swamps shows that in the 100,000 years leading up to the extinction, The Earth had gradually warmed by about 5 degrees Celsius due to this volcanic activity. This warming may have actually helped dinosaurs expand their habitats. More importantly, this pre-existing warmth might have buffered the planet against the worst of the asteroid's impact winter, preventing a complete deep freeze and helping some life forms cling on. So the asteroid was the killer. The volcanoes, far from being a partner in crime, might have inadvertently softened the blow and aided the recovery for the survivors. But the plot thickens even more when we look at the fossils themselves. For a long time, scientists believed that dinosaur diversity was already declining millions of years before the asteroid hit. The fossil records seemed to show fewer and fewer species, suggesting they were already on their way out. This painted a picture of a fragile group just waiting for a final push. We now know this is wrong. In 2025, a landmark study revealed that we were being fooled by a simple problem: sampling bias. There are fewer exposed rocks from the final million years of the Cretaceous period for paleontologists to search. It's not that there were fewer dinosaurs. There's just less evidence for us to find. In fact, the opposite was true. Dinosaurs were thriving. Right up until the very end, new species were evolving. In North America, distinct dinosaur communities, or bioprovinces, existed side by side. The cooler north had Tyrannosaurus and Triceratops. But in the warmer south, in places like New Mexico, a completely different set of dinosaurs flourished, including the colossal 100-foot-long Alamosaurus. These were not struggling, dwindling populations. They were vibrant, diverse ecosystems, perfectly adapted and successful. They weren't declining. They were at the top of their game. And then, in a geological instant, they were gone. The extinction was total. Non-avian dinosaurs vanished from every continent: North America, South America, Europe, Asia, Africa, Antarctica. But it wasn't random. The survivors tell a story. Small, burrowing mammals made it. Cold-blooded crocodilians and turtles survived. And of course, one group of dinosaurs did survive: the birds. Within just 300,000 years of the impact, a blink of an eye in geological time, mammals began to rapidly diversify, filling the empty ecological niches left behind. The age of dinosaurs was over, and the age of mammals had begun. So, did one asteroid kill all the dinosaurs? The answer, according to the latest science, is a resounding yes. The asteroid was the primary killer. Its impact triggered a global catastrophe so sudden and so severe that even 165 million years of evolutionary success couldn't stand against it. The volcanoes didn't cause the extinction, and the dinosaurs weren't in decline. The story of the dinosaurs' extinction is not one of inevitable failure. It's a story of cosmic bad luck. A thriving, complex world, full of magnificent creatures, wiped out by a random event from space. It teaches us a profound lesson about life on our planet. It is both incredibly resilient and terrifyingly fragile. Gradual changes can be adapted to. But instantaneous, catastrophic events are a different beast entirely. The dinosaurs' reign ended in a flash of light. A reminder that nothing is forever. Thanks for watching. If you found this journey into the deep past as fascinating as I did, make sure to subscribe, and hit that notification bell for more stories from the frontiers of science.